Whoa, whoa. Okay. I don't want that on there. Why is that on there? There we go. Okay. So, now, what is the problem here?
We don't know age.
No, we don't. We have two variables. So here's what we're going to do. They gave us this 1 liter business for a reason. First of all, I'm going to write down, I'm going to try to at least get this with one variable, and I'm thinking the variable would be R just because I have it already in 2 different spots. So what I'm going to do is I am going to write down 1 liter equals 1,000 cubic centimeters. Why? Because I don't typically measure a radius and a height in terms of liters. Well, you can't, right? So I'm going to put them in cubic centimeters so I'm able to rewrite the expression in terms of centimeters. Okay, once again, you are not expected to know the volume formula, but the volume of a cylinder equals pi r squared times height. And we already know it equals 1,000, correct? Can you guys write an expression to get h alone then? What would be an expression to get h alone from that? How would I get h alone? H equals, 1,000 over pi r squared, and I'm going to write it that way because then when I put it in the surface area formula, I'm going to have all r's. And actually, a lot of things cancel out, and it ends up being kind of nice. Okay? So, remember, don't forget the big picture here. We want to minimize the surface area, so we're going to write an equation for the surface area. To minimize, we're going to find the critical numbers, and then see if they're minimums or maximums. Okay, so I'm going to write S of R equals 2 pi r squared plus 2 pi r, and instead of h, I'm going to write times 1,000 over pi r squared. I just took out my h and rewrote it that way. Okay. I guess I don't need a times and a parentheses. Okay, so this pi r is on top, this pi r squared is on the bottom. Can you simplify that at all? So I still have 2 pi r squared up here. But doesn't a pi cancel and one of the r's cancel? Alright, so I have a pi that's going to cancel and one of the r's is going to cancel. So on top I have 2,000. Why? Because 2 times 1,000 is 2,000. And over r. Okay. Now before you get your panties in a bunch about the 2,000 over r, no, you don't have to use quotient rule. Let's rewrite it as r to the negative 1 power. Capiche? Alright. Now, since I'm minimizing, I am going to take the derivative. Would you do that, please? So, S prime of r. You guys do it. Let's see what you got. Did you get that? Alright, let's rewrite it as a fraction. 4 pi r minus 2,000 over r squared. Okay. Now here's the deal, guys. when you're given fractions like this, because I want to find the zero, if I can get it to be one fraction, the zero is where the numerator equals 0. Think about that again, okay? Because isn't the fraction 0 where the top is 0? So I'm going to try to get these together. Notice none of, really, how much calculus have we actually done so far? That was barely anything. So finding a common denominator, how would I find a common denominator?
You multiply the 4 pi r by r squared over r squared.
Let's do it. I'm gonna put this over 1, okay, and I'm gonna multiply this by r squared over r squared. You see what I'm doing? So I have 4 pi r cubed. Are we following that? Minus 2,000 over my common denominator of r squared. Okay. The minimum is going to occur at a critical value. So I'm going to write down here, we're trying to find critical numbers now. Critical numbers are where s prime of r equals 0, which means that's where 4 pi r cubed equals 2,000. Let that sink in a second. Because if 4 pi r cubed equals 2,000, that would make the top 0, correct? Don't use your calculator yet, Noah.
Well, I got it.
I'm going to have you do it exactly. Okay, so let's find this exactly. It's not going to be necessarily nice, but we should get used to at least, like if you were just asked to find the radius in a non-calculator portion, you can at least write an expression for that. So divide by 4 pi, correct? What's 2,000 divided by 4? 500. So we get r cubed equals 500 over 4 pi, right? And then we take the... Oh.
Yeah.
Jolly Rancher. Okay. And then I take the cubed root. So my exact answer is this. Now, do we know what that is? If it was the cubed root of 27, we would know what that is. Do we know what this is off the top of our heads? No, we do not. But at least if I had to, I could write an expression for it. Okay. Now, you can get your calculator out and tell me what this is approximately. Do you get 5.419 centimeters? Okay, to confirm that this is a minimum, I would actually still have to do the double derivative. Now don't freak out again. Go back to this one. Go back to this right here. What would the double derivative be? 4 pi plus 4,000 r to the negative third, correct? Okay. So I'm going to just verify over here that this is a minimum. 4 pi plus 4,000 r to the negative third. Are you guys all okay with me writing that like that? Did I go right to that? You can write r to the negative third if you want. And let's just confirm, if you put this in, I mean, think about it. If you put this in, you have a positive number here, correct? Plus a positive number here, even without doing the math. Isn't this going to be positive? Okay, so f prime of 5.419 is greater than 0. Therefore, a minimum, this means concave up, right? Therefore, a minimum occurs here. Okay. So I think the last thing is I've found the radius. I've confirmed that there's a minimum there because I wanted to minimize surface area. Shouldn't we find the height of the cylinder? And the surface area. Okay. All right. You guys can. Let's get our calculators out. So we have the radius here. Let's find the height. Go right back up to this formula right here. Okay, so 1,000 divided by pi times, I mean, if I wanted to be most exact, I'd have to actually type that in, but we'll just do this for now. And you get about 10.839. You can truncate, or 10.840. And I think it would be easiest to use this surface area formula right here, because didn't we write it in terms of R already? Okay, can you go plug 5.419 in and tell me what that surface area is when you plug it into this expression? Can one more person just confirm? Not that I don't trust Danny. I do.
Would you say 553.58? Yep.
Okay.
581 centimeters squared.
581
Yeah.
centimeters squared. All right. Now these are just two examples of the process. You're going to notice there's only 4 problems tonight, okay? Because they take a while to do. So we are doing 6, 7, 13, and 16 for homework.
Is that already on the road?
Let's